So I'm looking to improve the safety of my solar water heating system. Um, we use the solar panels to drive the immersion heater in our hot water cylinder. Where there is excess power, there's a whole system behind that, but I won't explain it here now. Basically, so the immersion heater is heating the water. The hot water, as normal, comes out the top of the cylinder, goes off to the house, and cold water comes in to replace it. So that's the basic system. What I've added is a destratification pump between these two pieces of pipework, and that pump is controlled by another Arduino, which operates a relay. There's actually a temperature sensor on the top of the cylinder. There's also one on the middle and one on the bottom. But the Arduino uses those temperatures to decide when the pump needs to be turned on and when not. So it obviously via the relay it puts mains onto the pump and will pump water from the bottom of the cylinder to the top. So basically it just pumps it around in this loop and will keep the top of the cylinder at a 60-degree nominal temperature, just over 60 actually because of Legionnaire's disease. But it will draw on the colder water from the bottom and destratify the tank. A friend of mine has got a very similar system and had a situation where the pump, which is identical to mine, the mains pump, stayed on over the weekend while they were away. And obviously that's not good. It ended up getting very hot. I've already got some software sort of traps in my Arduino code that picks up excess temperatures and that sort of thing and will shut down the system. But what I'm going to do, I think, is to add a thermal fuse to the pump body that will just interrupt this main supply. So it will pick up the temperature of the body, and I say if it does get above 90 degrees is my plan, then it will simply blow and cut the main supply from the pump. So if the relay stops working, for instance, it gets locked shut for some reason, contacts weld together, it would sort of prevent anything going too catastrophically wrong, or if the pump stalls for some reason, some debris in the pipework or something. So that's the plan. I just need to get some thermal fuses. Right, so I've got these thermal fuses that I've got off eBay, come in threes. I wanted to test one to make sure it trips out when it's supposed to. They're rated at 250 volts, 5 amps, 90 degrees C. So I believe they have some kind of alloy that's chosen to melt at a particular temperature. So it should go open circuit once it reaches 90 degrees and then just stay open circuit permanently. So it's a one-time protection device, basically. If something gets too hot, then it'll just disconnect it and so leave it disconnected. I guess on the assumption that there's some problem that needs to be addressed before it should have power applied to it again, in which case you'd replace or fix the problem and then replace the thermal fuse. So I've got three. I want to use one on the destratification pump upstairs, and I'm going to use one just to test it. I'm thinking I'll use this for a start, this ultrasonic tank. This has got a temperature control and setting up to 80 degrees C. So if I get it up to 80, this shouldn't quite trip. Maybe it will, but we'll see for a start. If that doesn't trip it, then that's good news, I guess. But I'll use a saucepan on the stove to get it up to 90 and just check that it trips around the right temperature. I've got this temperature probe, which is pretty accurate. I've calibrated it in the past, saying 13.5 degrees here in the garage, which, as it happens, is about right compared to this. So it's certainly not wildly out. So I use this to keep track of the temperature in here as I heat it up. Okay, so the power is on. This is set to 80. Yes, it is set to 80. And this thermometer is only showing 12.7. So the water out of the tap is colder than the air temperature in the garage, which isn't surprising. But I think it is actually warming up. 12.7 to 1.8. So it is warming. I'll let that get up to steady temperature and measure it again. Yeah, and this is going to work. This actually displays the current temperature flashing and the set point up here, and it's showing 45 or just below actually. It's been on for an hour. Checking with this thermometer. Yeah, this is showing 46.5, 46.4. So yeah, they're the same, but there's no way it's going to get to 80 degrees, not in this ambient air temperature, at least here in the garage. I'm going to have to use a saucepan, I think. Okay, so the fuse is connected to the multimeter, showing 1.23 ohms, 76.3 degrees. Interesting, the resistance of the fuse is actually falling. It's now dropped to 0.7 ohms. We're up to 84 degrees. I wonder if that's because the alloy that's in the fuse is starting to sort of coalesce and reach its melting point. Melting point up to 87 degrees. Trying to keep the temperature even, down to 0.7 ohms still, 0.68 ohms. That's gone. Okay, so 87.9 degrees. Okay, so that is now useless. Okay, so 87 degrees, that's pretty close. And if anything, it goes slightly early rather than the 90 degrees it's rated at. So I guess it's better that it goes slightly early rather than slightly late. So yeah, they certainly work. And it's interesting that the resistance fell as it approached the breaking point, melting point. But there we go. Okay, so this is the destratification pump that I want to protect. So if this were to run continuously because something had failed in my Arduino software or for any other reason the relay sticks or something, then that would be bad news. Wouldn't actually or shouldn't do too much harm. But I've got this fusible thermal fuse in there anyway that at least will protect against that. And the water shouldn't be above 60 degrees or 65 degrees or so at this end of the pump. But the windings do get warm, certainly, and I'm pretty sure they would get up to 90 degrees if it was running continuously flat out for more than, I don't know, an hour, say. In practice, it never runs more than a minute. It normally runs for something like 10 seconds just to keep the cylinder from being stratified. So it's only when it's just warming up, it only goes for 10 seconds or so. Anyway, I was going to just attach this thermal fuse onto the top. Just have it resting on the metal of the body. And I'll attach it with some zip ties. I'm going to put a bit of foam on top. This is closed-cell foam. It's actually a camping mat. So I'll put a bit of that over the top just to make sure that it gets the heat from underneath and it doesn't just radiate it away. It does reflect the actual temperature of the pump body. Just secure these zip ties. Don't need to be over tight. Just enough to snug it up, stop it from moving. Right. So I'll put the zip ties on, tidy those up, tidy up the wires a bit, put a little pen mark on it so I remember what it is, and if something fails, hopefully I can remember that that's a likely cause of the problem. So yeah, see how it goes. Hopefully it will never need to use, but at least it's there as a backup just in case. Okay, thanks for watching.